Saxon Advanced Mathematics, Lesson 78. Today we're going to start fooling around with a new shape. It's called the hyperbola. It behaves in a lot of ways like an ellipse. So let's review what we know about the ellipse in order to get our heads on straight for the new material. An ellipse can go tall and skinny or low and long. I'm going to draw this style because it fits on my paper better, but they both operate more or less the same way. We have focal points, and then we have vertices, right? Okay, so what I'm doing is I'm putting these 2 points equally distant from each other, and then I'm putting these 2 points equally distant from each other, and then these two. And I'm going to draw the circle first, and then I'm going to label all of those points. Okay. This is what we call the major axis. It's the long part of the ellipse, and we call the points on this major axis A. Right, so this would be positive A and 0. This would be negative A and 0. This is the minor axis on this kind of hyperbola. And here we would label the point 0B, and this point would be 0 minus B. If we twisted this and we had it long and skinny, then these would be the A's and the shorter side would be the B. Always the longer side is A, the shorter side is B. We call these the focal points. We haven't done too much with those yet, but we're going to come back to those. We remember that if you imagine this is a bulletin board and we used push pins at the 2 focus points, we could connect a string between them. And that string, we'd put our pencil in the edge of it and we'd pull as far as the string would let us and go all the way around. That's how we would get the shape of this ellipse, is by this string that connects them. We also know that this distance we can call A, which makes sense because from here to here is A. So yeah, that's another way of saying it. And then this distance, this is also A. And then this distance is B, also B. All right. The formula we use for this one would be x squared over a squared. A squared is always associated with the major axis. I'll show you the formula for the other style. And then the other axis, the minor axis, is always associated with the b squared, and then they equal 1. This is the formula for what I'm going to call a horizontal. But we can change it up ever so slightly. This time we'll bring the y squared first and associate it with the a squared. And then we'll have the x squared with the b squared, again equal to 1. This is the vertical style, which does not match to our picture. Okay, so that's what we know about the ellipse. And notice, please, that we're adding the 2. That's the big difference. When we draw the hyperbola, there's minus signs here. All right, so let me flip to the next page and draw you some pictures of a hyperbola and show you how that works. Just like the ellipse, there are 2 versions of it. The words horizontal and vertical don't work quite as well, but we can use them to describe the 2 different styles of hyperbola. In these, we also have A's and B's and F's, but the way that we do them looks a little different. These are our A values. Just like before, we have an A and a minus A. This time, our focal points are on the outside. I'm gonna call this F1 and this F2. Remember before, the A's were further out and the F's were kind of on the inside. Now it's reversed. What? That's weird, right? But in this example, the x-axis is our major axis, and so the hyperbolas kind of hug the major axis, right? The axis is going through the hyperbola. And this is the way we write the formula. X squared, because that's the major axis, and our focal points are a surefire way to show us where the major axis is, right? So we see the focal points are on the x-axis, so we know that the x is the major axis. The y squared is the minor axis. This time we subtract them and set them equal to 1. This whole relationship between the x and the A, because that's the major axis, that's exactly the same as the ellipse. What's different is that minus sign. Now let's draw the picture for A. You can call this horizontal because the hyperbola's center on the horizontal axis. So let me do this. And now we'll do the same pattern for the up and down style. I'm gonna put these as my focal points. So this is F1 and F2. As soon as you see your focal points, you know which one is your major axis. That's the easiest way to tell. So now I know that the y-axis is my major axis. I know that I've got points inside that are 0, A, and 0, minus A. A also tells me this is the major axis. And our parabola is going to look like this. Right? Our points, like I said before, our points A, and negative A are closer to the origin. The focal points are on the outside. That's what makes this a hyperbola. With an ellipse, they're the other way around. The focal points are inside. And here we see that we need to do the y squared first and associate it with the a squared because this is the major axis. Again, the focal points are the best way to know that. We subtract the minor axis over b, and that is equal to 1. So this is the other style of the problem for a vertical hyperbola. Over here, remember, I only drew the picture for the horizontal. We could draw the picture for the vertical if we wanted, but because we're reviewing, I just skipped over that step. Okay, great. So how do we graph these little suckers? Let's find out. There are how many examples in this problem? 1, 2, 3. I will say that once, everything always feels weird at first, right? Here, I have to put it in my sun protector. Everything always feels weird at first, but once you get the hang of these, most students find this kind of fun. There, it's my high-tech sunscreen, which I know makes my page kind of dark, but hey, can't have it all, right? Okay. The sun will go behind a cloud. I think it has already. Let's see. It's better. Oh, complications. Okay, here comes our equation that we're supposed to graph. We can tell by that minus sign that we're going to be making a hyperbola rather than an ellipse. So that's a big clue. We see, okay, the x squared is associated with the first term, so we can see this is going to be a vertical. The x squared, the x-axis is the major axis. We know that because it's in the first place. The y squared is the minor axis because it's behind the minus sign. How do we graph it? The first thing we do is we let y equal 0. Okay, and we solve for x. We do that first because x is the major axis. So we say x squared over 9 minus 0 squared over 4 equals 1. That all goes away because this is just 0, right? So I get x squared over 9 equals 1. Cross multiply. X squared equals 9. Take the square root of both sides. X equals plus or minus, oops, I forgot the equal sign. X equals plus or minus 3. Okay. I'm going to put my graph down here so I have a little bit more room to work. So 3 is where my points are going to be. My vertices, okay? In other words, my the curving point of the hyperbola. You'll see in a minute when we draw it. Okay, I don't know the actual value of my focal points, but I don't really need them yet. They're going to be out. We know that our A value is closer, right? This is my A value. This is minus 3, 0, and this is positive 3, 0. Okay, now we're going to do something additional. We're going to let, x equals 0, and we're going to solve for y. That's going to give us a really helpful piece of information, and this is where it gets kind of fun. Okay, and I'm drawing a box to separate this part out. Okay, so let x equal 0. So now we have 0 squared over 9 minus y squared over 4 equals 1. This turns into a big fat 0. So now I just have minus y squared equals 1. I'm going to multiply both sides by minus 4 to get this y squared by itself. Right? So I'm going to multiply by minus 4 and minus 4. That cancels this and this. So now I have y squared equals minus 4. Okay, that looks kind of weird, but I'll take the square root and I will get y equals plus or minus, square root of 4 is 2 with an I, because there's a minus sign inside of our square root. Whew, well, that's kind of weird, but the good news is we get to ignore the I. Okay, so this tells us that on the y-axis, we want to measure and mark the point 2 units up and 2 units down. Now, look what crazy thing we do. 3. We draw a rectangle. I think I just wrote inside of my rectangle. Maybe not. We use these 4 points to make a rectangle that goes around the origin. See why I did that? Super easy. Now, here comes another fun part. We're going to draw in what we call the asymptotes. The asymptotes are the diagonals of the box. They go through the origin and then through each of the corners. I got a little messed up there, ignore that. All right, from the origin, out the corner of the box, in all 4 directions. These are lines that our hyperbola is going to approach but never touch. What's cool about them is that they guide the way we draw the hyperbola in, right? Because what we're gonna do is I'm gonna use a different color so you can see a little better. We're gonna use these as our vertices. We know that's right. We know the x-axis is the major axis that's gonna cut through the hyperbolas. So we're not using this space, we're using this space. So I use this as my vertex, and I draw my hyperbola so that it approaches those diagonal lines, but it never touches them. Ooh, pretend it's perfect. And we do it on both sides. There's something satisfying about drawing that big X, getting our asymptotes, and then drawing the hyperbolas within that context, okay? So the first thing we do is we solve for the major axis, and that gives us the vertices, we graph. Then we solve for the minor axis, and that gives us the other points of our box. We do get an imaginary number, but we just pay attention to the value, +2, -2. That gives us a rectangle. That gives us the asymptotes. And now it's very easy to draw a hyperbola. Wow, that's kind of cool, isn't it? Let's do it again. Did I tell you there were 3 in all? I think I did. Example 78.2. Sketch the hyperbola, and then we're told it's y² over 4 minus x² over 25 equals 1. And find the equations of these asymptotes. Oh, the last one told us to do that too. I didn't do it. Oh well, we'll do it this time. It's not hard. Okay. Remember that the first term tells us the major axis. The number is smaller, but that's okay. This is the major axis. And so that tells us that this hyperbola is going to go like, it's going to open up and down rather than side to side, right? The hyperbolas hug the major axis. All right, so, but I can see my numbers are kind of opposite that, so I'm just going to draw kind of a big open graph and hope it makes sense. The first thing we do is we solve for the vertices, which is we set the minor axis equal to 0. So then I have y² over 4 minus 0 over 25 equals 1. This is all turning to 0, and we get y² equals 4, and so we get y equals ±2. I know it looks like, why do we even do this calculation? We could just take that number. That's a shortcut as long as our hyperbolas are centered on 0. It wouldn't necessarily work if we had other adjustments, but we're not doing other adjustments. So if you want to sort of shortcut this, it will work. Y equals ±2. So this is my major axis, 0, +2, 0, -2. I know my focal points are out here somewhere. I'm just going to write them to remind me. Okay, so now I know I've got my vertices. I'm going to make nice big dots there. And then my things are going to go like that and like that, because they're going to hug the major axis, which is y. Woo, it's all coming together. Okay, now we do step 2. We set the minor axis equal to 0. And we will have 0² over 4 minus x² over 25 equals 1. Then we get, that all goes to 0, we get minus, no, I'm going to multiply by minus 25 over minus 25. Minus 25 on this side, minus 25 on this side. This all goes away. I get x² equals -25. I get x equals plus and minus 5i. Okay, So then I have to measure 5 units out. This is my minor axis. It just has a greater value. That is okay. Now that I've graphed the second pair of points, that allows me to draw my box, my rectangle. Oops. That allows me to draw my asymptotes, which go from the origin to the corner of the box. Okay, they're a little wobbly, but it's okay. My hyperbola is centered on the major axis. I remind myself of that. But this is a very, whoops, should always be getting closer. This is a very fat and open hyperbola. That's the consequence of having the major axis value smaller than the minor axis value, but it still works. We just have a weird, very wide open hyperbola, but that's correct. The last step, which I skipped on the last problem, oops, don't tell John. We find the equation of the asymptotes. Okay, so the third part was to graph the box. You graph the rectangle, you graph the asymptotes. That's such a weird word. And then you graph the hyperbola. Now the fourth one is we're gonna find the equation of the asymptotes. Sun guard. Okay, that is actually super easy if we just look at our graph, all right? We know that it's gonna follow the pattern y equals mx plus b. We know that b is the y-intercept. It's where the line crosses the y-axis. We can see it's at 0 both times. Yay, that means we don't even have to worry about a b. That means we just have to find the slope. Remember, the slope, if it's positive, is the rise over the run. This is old school, right? If it's a negative slope, it's the sink or the downward over the run. Always we measure to the right. Okay, this is old school information that I'm shoving back in your face because we haven't talked about this in quite a while. So we can see that our y-intercept is going to be 0 in both cases because it crosses at 0. That means all we have to do is calculate the slope. So this one I always do first because this is the positive slope. Remember the pictures in Algebra 1 and 2 where the little car was driving up the hill? Yeah, positive slope. So y equals, so we measure the rise over the run. It goes up 2 and then over 5, going from this point to this point. Up 2 over 5. So this is going to be 2/5 x. That's the equation of this asymptote. Now, this other one we know is going to be a negative slope. It's the sink over the run. So I'm going to use this point and this point to calculate. It goes down 2 and over 5. So this is negative 2 over 5x. Again, plus 0, because 0 is our y-intercept. We don't even have to write it. And this is the right answer. Okay, so finding the equation of the asymptotes is a breeze. Your graph has all the information you want. Just compare the origin to one corner for this one and the origin to this corner for the other one. You should always get this relationship. As long as our work is centered on the origin, which we're not going to take it off the origin in this class. Okay, there we go. Let's do one more. graph the hyperbola. Well, that looks messy, doesn't it? I don't like it at all. So what we need to do is we need to bump the plane number over. So we'll add 36 to both sides. And now this number needs to be equal to 1. So what we'll do is divide every term by 36, because that's what we need to do to set this equal to 1. Now we can see, all right, 4 over 36, that cancels, so I'll have y squared over 9 minus, this cancels, I'll have x squared over 4 equals 1. Okay, looks much, much better. That I can graph. This time we're going to use the shortcut. We're not going to go through the formal procedure of setting the minor axis equal to 0 and then the major axis equal to 0. We're going to simply take the square roots of these two numbers. Quick and easy. That's what I like. Okay, so we know that this is the major axis. This is where the focal points are going to be. On this one, we know that it's going to be plus and minus 3 are our values. I'm not going to use the exact blue lines. I want to make it a little bit bigger. So we're going to say this is point 0, positive 3, and this is 0, negative 3, and we know that our focal points are somewhere beyond the vertices. Okay, so far so good. Now we're going to draw a rectangle. We're essentially setting this equal to 0. No, we're setting the other one equal to 0, sorry. And we know that we're going to get plus and minus 2i. We know we're going to ignore the I. We know that that means we should go 2 points out, right? Y equals plus and minus 3. X equals plus and minus 2i. I'm graphing the 2's here. This is 2, 0. This is minus 2, 0. We ignore the I. We know it's there, but we don't need to deal with it. Now we draw our box, our rectangle. Sorry, math teacher needs to use math words. That's a little hinky. Pretend it's not. Now we draw our asymptotes. Oh, now. That looks really bad. Sorry. Pretend it's perfect. There are our lovely asymptotes. Now we always have to stop at this point and go, wait, are we going this way or are we going this way? We could do it either way, right? The asymptotes don't resolve that for us. We have to look at either our focal points or go back to our equation and figure out which is our major axis again, right here. I personally find the words horizontal and vertical less helpful for hyperbolas than I do for ellipses because it's not quite as clear what's a horizontal and what's a vertical. I have to look at the major axis and then I have to remember that the hyperbola is going to wrap itself around the major axis. So it's going to go this way, like this. Remember, these points are the vertex, the endpoints, if you will. So it's going to go like this. And like this. Our hyperbola will get ever closer to the green line. This one looks like it's going away again. That's not right. It's going to get ever closer to that green line, but it's never going to actually touch. That's the definition of an asymptote. Okay, this is our hyperbola. Up and down. The vertex is 3 and negative 3. It's centered on the major axis, which is the y-axis. Last step. Equation. Find the vertices. Okay, these are the vertices. So this is part of our answer. And the equations of the asymptotes. I believe it's pronounced asymptotes. Okay, again, we know that they're going to take the form of y equals mx plus b. We know that b is the y-intercept. We know that they're crossing, both lines are crossing the y-intercept at 0. That means we don't have to worry about the b. We just do our slopes. Let's do the positive slope first. It's the rise of 3 over the run of 2. So this would be 3 over 2 x. And then we do the same thing, only in the negative direction. I'm going to compare this point to this point, right? Last time I did this point to this point, and I went up 3 and over 2, although you really can't tell by the shape of my graph. You have to look at the numbers. Now I'm comparing this point to this point. It's a negative slope, and it's the sink. I go down 3 and then over 2. And that confirms my earlier statement that these guys will always be negative versions of each other. All right, that's everything we needed to know. Yay! I haven't been happy facing, but I'm very happy about this lesson. Okay, I hope you find those kind of fun, drawing the boxes and the X's. I hope you have better luck than me. And then that allows you to draw your hyperbolas. All right, have fun. Goodbye.